You know that feeling when you walk into a room, stop dead in your tracks, and literally have no idea why you went in there? Or, oh, how about when you're struggling to recall the name of someone you just met 5 minutes ago? We've all been there, right? And we almost always treat these moments as a personal failure. We get super frustrated, kind of just assuming our brain is glitching out on us. But today, we're going to explore a mystery that completely flips everything we think we know about the human brain right on its head. We are diving into a groundbreaking biological perspective on memory, one that reveals a really curious and honestly incredibly elegant truth about what is actually happening inside our heads when things slip our minds. I want you to think about this quote for a second. The advantage of a bad memory is that one enjoys several times the same good things for the first time. Friedrich Nietzsche. It's a pretty profound observation, isn't it? It frames the loss of memory not as a deficit, but as a unique kind of advantage, an opportunity to experience things brand new. We're going to use this idea to ground our whole scientific journey today, because it turns out modern neuroscience is actually starting to catch up with Nietzsche's intuition. So I'll ask you this. What if forgetting isn't a flaw, but one of the greatest abilities of the human brain? Get ready because the research we are looking at today reveals a massive biological plot twist. Forgetting? It's not an accident. Section 1. Passive decay versus active erasure.
Let's dive in.
For decades, experimental psychology basically taught us that forgetting was just this passive process. Think of the old passive decay model, like a photograph left out in the blazing sun. The idea was that our memories just naturally fade away over time because our biological materials are unstable, or they just get buried under this giant pile of new, incidental information, making them super hard to retrieve. But researchers are now shifting toward a totally different paradigm: active forgetting. This proposes that the brain doesn't just sit back and let memories fade. Instead, it uses a deliberate biological erasure process. It's literally an active system built right into our neural hardware. Whenever you acquire new information, it physically alters the state of certain neurons, creating what we call a memory trace, or an engram. But this active forgetting process, it means the brain actually deploys specialized mechanisms. Think of them as microscopic biological cleanup crews that hunt down and actively degrade these molecular memory traces. They're physically sweeping the engram away. So it's not a storage failure at all. It's targeted demolition.
Section 2. Meet the forgetting cells.
This brings us to a truly mind-bending concept known in the scientific literature as intrinsic forgetting. This is defined as the brain's chronic signaling systems that function to slowly degrade molecular and cellular memory traces. I really want to emphasize that word right there. Chronic. This means that forgetting is actually the default state of your brain. It's a homeostatic process operating continuously, 24/7 at a low level. It's basically an eraser that is slowly but constantly rubbing out newly acquired memories just to return your brain to its baseline balance state.
Section 3. The molecular mechanics.
So how does this actually work? Well, imagine a literal forgetting cell in action. Let's say a dopamine neuron is communicating directly with the memory cell, the engram, right next to it. Now, we usually think of dopamine as this feel-good reward chemical that helps us learn, right? But in this context, dopamine acts as an ongoing, relentless forgetting signal. The dopamine neuron is chronically active, just continuously whispering to the memory cell to dismantle the very information it just stored. It's essentially a four-step biological takedown. First, dopamine is released by that forgetting cell. Second, it activates a very specific receptor, called DMB, on the memory cell itself. Third, that signal triggers a protein pathway that wakes up a molecule called RAC1. Now, RAC1 teams up with another protein called cofilin to remodel the actin cytoskeleton. I know, that's a super technical way of saying it. It breaks down the physical, structural scaffolding of the brain's synapse. And then step 4. Because of that structural breakdown, the memory trace is completely actively erased. It's exactly like a microscopic sculptor chipping away all the excess stone. But hey, the dopamine sculptor isn't the only tool the brain has. There's another fascinating mechanism called neurogenesis. This is the literal birth of new neurons in the hippocampus. Now, common sense would probably tell you that growing new brain cells would improve your memory, right? Actually, research shows that as these brand new neurons are born and integrate into your brain, they remodel the existing circuits and clear out the old memory traces. It's exactly like installing a massive new operating system on your computer that just overwrites the old data. And this perfectly explains why infant mice, and human babies for that matter, whose brains are constantly growing and overwriting themselves with new neurons, forget things so incredibly fast. Section 4. Why we must forget.
So why go through all this trouble? Well, the crucial takeaway here is that forgetting is an absolute requirement for our survival. Just think about the sheer overwhelming volume of sensory data you process in a single afternoon. If you remembered every single detail forever, it would lead to paralyzing information overload. Erasing irrelevant data frees up cognitive space, and that directly allows for flexible decision-making. It lets us adapt to new environments. For example, you absolutely need to forget exactly where you parked your car yesterday so you have the brain space to remember where you parked it today. Plus, this act of forgetting reduces what scientists call unrewarded perseverance. That's just a fancy way of saying it stops us from endlessly repeating failed strategies or obsessing over a bad day. Forgetting useless trivia or, minor embarrassments, it's not a glitch. It is absolutely vital for your sanity.
Section 5. The memories we keep.
So, with all this erasing going on, how do we remember anything at all? Ultimately, it comes down to an epic, eternal competition inside our heads. On one side, we have intrinsic forgetting, that constant biological erasure we just talked about, trying its best to wipe the slate clean. But on the other side, we have memory consolidation. This is the process that locks in and stabilizes the memories we actually need. Consolidation basically acts as the judge. When you sleep or when you experience something highly emotional or super important, consolidation mechanisms fortify those specific memory traces, making them highly resistant to the forgetting cells. So every memory you currently possess, it's simply a survivor, the winner of a microscopic tug of war.
We spend so much of our lives incredibly frustrated by our bad memories, just wishing our brains functioned like perfect high-def video recorders. But the science shows us that our minds are shaped just as much by the eraser as they are by the pen. The active clearing of the old makes space for the new, allowing us to adapt, to grow, and to experience the world with totally fresh eyes. So I'll leave you with this. If forgetting makes us who we are, what memories would you choose to keep forever?